Hello and welcome. In this video, we will cover how to create a technical dashboard used for troubleshooting, fault detection, and in-depth monitoring of your equipment on site. Let's start by creating a stacked graph at the top for state of charge, or SOC. We are using a stacked graph here to keep the layout consistent with the rest of the widgets. Click on Add Widget and select Stacked Graph. Drag SOC in from Templates and name the graph SOC. Next, let's bring in cell voltages for each battery module. The best way to display this and easily identify cell behavior is by using a heat map. Click on Add Widget, select Stacked Heat Map, and drag in all the cell voltages for a specific module. Give the widget a name. For example, IES2 Module 1 cell voltages. This process can be repeated for all other modules. Now, let's look at the gap between the lowest and highest cell voltage across the system. This is a useful indicator to determine whether the battery requires cycling or balancing. Click on Add Widget and select Stacked Graph. From the hybrid inverter, bring in minimum cell voltage and maximum cell voltage. If there is a large difference between these values, further investigation is required. Name this widget Min-Max Cell Voltage. At this point, let's save the dashboard to avoid losing any progress. We will call this dashboard Battery Details. Now let's look at temperatures. Again, we will use a stacked heat map. Click on Add Widget, select Stacked Heat Map, and bring in the maximum temperature from each battery. You can use the search bar to filter values. For example, typing max will help you quickly find all maximum temperature values across devices. This view makes it easy to identify thermal issues in any battery. Name this widget Battery Max Temperature. Next, let's bring in total battery voltage for each battery as individual graphs. Simply drag the total voltage value from each battery into an empty space on the dashboard. You can search for total to find these values more easily. Notice that all graphs are linked. When you hover over a specific time, that same point is highlighted across all graphs. This makes it easier to compare different data sources.
Now let's create a similar dashboard for PV performance. Start by creating a new dashboard. At the top, add a stacked graph for total PV power. Click on Add Widget, select Stacked Graph, and choose PV Power from Templates. Next, we want to verify that all MPPTs, or strings, are operating correctly. Since this plant includes both grid-tied and DC-coupled PV, we will analyze them separately. Click on Add Widget, select Stacked Heat Map, and bring in PV power per MPPT. Let's start with the DC-coupled system. Here, we can immediately identify an issue. PBD2, MPPT3 has no power output, which clearly stands out. Let's investigate further. Save the dashboard as PV Details so we can return to it later. Now, navigate to Device Types and expand the view. Select Solar Charger and then choose PBD2. To investigate the issue, drag both power and voltage into the dashboard. From the current date range, we can see that there is no voltage on this MPPT. Now, let's determine whether this is a new issue or a historical condition. Go to the time selector, set the interval to 1 day, and select the last 6 months. We can now see that since October 2025, there has been no voltage on this MPPT. We can go back even further by selecting an earlier date range. This shows that since commissioning in March 2025, this MPPT has never had voltage. This indicates that the issue is not new and may be expected. We can mark this as acceptable and remove it from the dashboard to avoid confusion. Return to the site dashboard to continue. Now, repeat the same process for the grid-tied inverters. Add a stacked heat map and include all grid-tied inverter values. Everything appears to be operating correctly. Name the graph and update the dashboard. Now let's look at exporting data. Everything visible on the dashboard can be exported by clicking the Export button on the left. Each stacked widget, such as heat maps, graphs, and bar graphs, will have its own tab in the export file for easier comparison. All standard graphs are grouped together on the first tab. To make the most of this feature, Let's create a dedicated export dashboard. Click on the Dashboard drop-down, select New Dashboard, and begin building. Set the date range to custom monthly and the interval to hourly. Now, add the key data points you want to export, such as battery charge energy, battery discharge energy, grid import energy, and consumption energy. You can also include technical values such as voltage, current, and power. Save this dashboard as Export Data. Now click Export. Within seconds, all the data will be available. For each measurement such as voltage, the export includes minimum, maximum, and average values. For example, if you want to find the maximum load voltage for the month, simply sort the max column. In this case, the site peaked at 249 volts, which is within NRS acceptable limits. That concludes the technical dashboard section. Thank you for watching. We hope this video has helped you better understand how to use technical dashboards. Please continue to our additional data and remote settings video to learn how to get even more from the platform. Thank you.